Welcome to Convocations today. I'm delighted to introduce our speaker. Professor Jon Pugmire is an assistant professor of physics at Snow College, where he teaches astronomy and physics courses. He serves as the assistant director of the planetarium and trustee of the NASA Utah Space Grant. He enjoys providing STEM outreach activities to the community, including for an upcoming solar eclipse. He is the director of the service learning program at Snow. He earned his PhD in physics from Utah State University, researching atmospheric physics in South America, New Zealand, and Antarctica. Please welcome Professor Jon Pugmire.
Thanks for having me. So my presentation is two topics, and hopefully it will be informative and help you learn about something called light pollution, but also it's going to show you the advantages, the cool things that you can do with physics and knowing how physics works and doing a little bit of math, that we can figure out how to get rid of. I'll lead it to a little bit, foreshadow what's going to happen. I'm talking about light pollution, and there's things that cause pollution, and one of those things happens to be the moon. So we'll talk about that later. So first I want to talk about light pollution and how we can save the dark skies. Who here is maybe not from Sanpete County and came here from the Wasatch Front or from a big city? Several of you, yeah. So one of the first things I always do in my astronomy classes is we take them out and we do observations. And when we go out for observations in my class, they come out here where it's dark. We go out of the city lights here in town, and they look up and they see all the stars, and there's so many that we can see here. And you can see the Milky Way, and sometimes we can see shooting stars. And then we bring out telescopes, and we can see a lot of cool deep space objects, galaxies and nebula. That's a thing that most people can't see. 90% of the world cannot see all the cool stars that we can see here in Sanpete. So light pollution is what I'm going to talk about. And light pollution is any bad light, any light going upwards, right? So there's lots of different kinds of pollution, water pollution, air pollution. Those all have complicated solutions. It take a long time. Light pollution is pretty easy. All you got to do is flip the light switch off. Turn the lights off or shield them down, and I'm going to talk about different types of light pollution and how we can solve them. Okay, so there's three different main types of light pollution. One is called sky glow. Sky glow is when, like if you're by a city and all the lights are glowing and making the sky brighten up. You can see this well from the Gunnison prison. That makes a lot of air glow, sky glow. When you drive up north to Wasatch Front, or whenever you go kind of by a city, you kind of see this. You can see the city in the sky first before you can see on the ground that there's a city there, because the lights are bouncing off of the road or bouncing around or shining upwards, and everybody has the lights on, so then it looks like that. So that's sky glow. And you can see in this picture that it limits the amount of stars and the galaxy that you can see because of all the sky glow. Another one is called glare. So glare is just when the lights are shining in your eyes. So if you all know this when you drive by somebody with their high beams on that you can't see. There's some apartments around here that have lights that shine out into the road. Anytime when the lights from a house or a street are shining into your eyes instead of like down on the ground, that would be glare. And then the third one is called light trespass. So light trespass is if you have a light outside of your house and it's made to light up your sidewalk or your parking lot or your driveway or whatever, and then it goes actually to your neighbor's house, right? It's trespassing onto places that it shouldn't go or that it doesn't need to be lit up, that would be light trespass. Okay, so these are the different types of light pollution, and there's some consequences that come from light pollution. So for one thing, there's ecological impacts that happen from light pollution. So, for example, it's not a big problem here because we have no sea turtles, but little baby sea turtles hatch, and they're trying to go out to the water, and they have to make it to the ocean before the birds and whatever else come and eat them, right? So sometimes, though, they get distracted by the lights, and they go the wrong way, and they go towards the city, thinking that that's the light of the ocean. That's what the little baby eyeballs don't know what they're looking for. They just look for light and kind of go towards what they think is the ocean, but it turns out to be the city lights, and so they get lost. Same thing with birds. Lots of birds, when they migrate, they are attracted to city lights, they change their migration patterns, they run into glass windows. All sorts of things happen when birds are migrating. And their impacts from light pollution happen to all sorts of natural things. Probably right now, the deer like light pollution because they know, oh, that's a city, so I can go in there and eat all the tulips and all the other flowers that are growing. But usually they do have bad impacts on wildlife. Another one happens is like trees and plants. It changes the seasons for the plants. So if there's a tree by a light, it might think that it's still summertime, so the leaves will stay on later than they should, when they should fall off in the fall time. And the same thing happens in the spring. They might blossom too early, thinking that it's warm, but really it's not warm. It's just one side's getting a little light from a street light or whatever, and so then they blossom too early, and then a freeze comes, and then they all die or lose their blossoms for the year or whatever. Okay, so also, any time that there's light pollution, that's wasted light, and that wasted light costs money. And so billions of dollars are spent on lights that are shining up into the air they don't need to, right? So if you have lights, you can keep them on if you want to, or the best way to save money is to just to turn them off, but you can also design them, buy them, that they're pointed downwards so they don't shine all over the place. And so that light pollution is a waste of energy, which is a waste of money, right? So if you're paying your utility bills, you're wasting your money for that. And that also causes, we have to have a power plant running somewhere to control that light. And so that's added CO2 emissions into the atmosphere that we don't need. All right, so another one is human health. So everybody here probably has a smartphone, and most of you probably have a setting on your phone that turns it into night vision, right? So at nighttime, it changes kind of red. So at nighttime, you need to get off your phone before it's bedtime. That way your brain can learn how to fall asleep. And so your brain you have melatonin, and this helps you fall asleep. And so if you're exposed to bright daylight, it ruins your rhythms, your circadian rhythms that help you fall asleep. And so a good way to fix this problem is just to choose lights that are red, right? So this is why your phone has red settings at nighttime, or why inside your house your lamps maybe in the evening should be red instead of bright daylight colors. Okay? So over millions of years, people have been able to look at the stars and see the stars. There are 88 known constellations, and anciently there were 48 constellations. And today, people don't really appreciate them maybe as much, or we don't understand them. But anciently, people knew the stars, they knew the constellations. They could see some other objects, the phases of the moon. And so, looking at the nighttime sky is a pretty awesome experience. And for people that have never done it before, it's pretty inspiring. And we get to do that here in San Pete and in small communities that maybe bigger cities can't do. So I have a little activity. So I want you to find the stalker. Another thing about light pollution is maybe people will say, well, we need the lights on for safety. But bad lighting actually is not very good because it doesn't help you, prevent dangers like the stalker. Can you guys see him? So probably maybe some of you can kind of saw him. But here, if I cover the light, now you can see the stalker. Some old guy. Okay. So probably not a stalker. Grandpa. Okay. So so good lighting design that also diminishes light pollution can also help these other things. Like we can still feel safe in a college campus. We can still feel safe on your dorms or your apartment complexes with lights that are designed appropriately, that still help you feel safe, but are also not pointed upwards and causing light pollution. Okay, so it's actually a myth that more lighting is safer. What we really need is better designed lights, and then that will make it so we can still be safe and prevent light pollution. All right, so here's a map, and it's going to skip through the future in different time, and it'll go cycle through it a couple times. But this shows light pollution. And all of these lights, this is how you can tell where cities are in North America. And this is showing per year, as years go by, you can see the future that the light pollution increases as time goes on, right? As people build more and more buildings, more and more street lights, more and more apartment complexes or skyscrapers or whatever, it causes more light. And we happen to live in the best spot. We live over here in Utah, and if you notice, our spot's pretty dark. But we don't have to do this, right? So if we just design the lights appropriately, we can mitigate some of those consequences of light pollution and keep the dark skies and still grow. So I'm not saying we need to live with no light pollution, with no lights. and we can't have cities. It's okay to have cities, it's okay to have growth, but we can design our things so that way they decrease this. Okay, so I'm going to zoom in. So I have looked up on a map, and I found San Pete and Ephraim, but they're not very interesting because they're pretty small and they don't change. So we're actually doing pretty good here in Ephraim. But so you guys can go here. This is lightpollutionsmap.info is a website you can go to, and you can zoom in. It's like a Google map, and you can go anywhere you want to, and you can set different dates. So here I selected Utah County. This is the southern half, so it's pretty close to where we are here. Maybe you can see on there Payson and Spanish Fork just over the mountain north of us. So this is what the light pollution looked like in the year 2012. And then you fast forward to 2022, and it looks like this. So I can cycle back and forth a little bit. Right, so Spanish Fork, that's like the complex of all the commercial buildings. That's where like the Costco is, and there's a Walmart right there, and all sorts of stuff. So as you can see, and then down here in Santaquin used to be small, and now there's more and more houses going into Santaquin, and same thing with Payson. So as more and more places go in, you know, the pollution, the little bubble of light coming off of people's houses and street lights spreads out. And then this is the same thing, but this is northern Utah County. So this is the north end of Utah Lake. And the part I want you to look at really is over on the left-hand side is Eagle Mountain and Saratoga Springs. Those two towns didn't used to exist very much, and now they're much larger. And you can see like Lehigh, that's where the Cabela's is, and Adobe and all the IT businesses, right? So watch Lehigh along the freeway there in Eagle Mountain. So 2012 and then 2022. Right? So with a little bit of planning, we can prevent this from happening here. Otherwise, it's going to happen everywhere. So that's my whole goal, my call to action for all of you people, is no matter where you live, there's things that you can do to mitigate it. And the first thing really to do is to start at your own house and look at your own house, your own lights. Maybe if your lights are on too much at your neighbor's house, you could shoot them out or something, or get a shovel and smack them, break the lamp or something. Just kidding, okay. But maybe you can put stickers. Go grab some stickers and stick them all over the top of the lights. Anyway, so I've taught this in my classes, in my astronomy classes, and I've had some students that go out and they do this with their farm or their house, and it's pretty easy to go out and switch out the lights and make them motion sensor lights or whatever. So a couple of tools I want to show you to help is there's some apps that you can get on your phone, and these are called Globe at Night and the Dark Sky Meter. These two apps you can put on your phone or other devices, and then you can walk around and help you measure light. And when you do that, you're helping doing citizen science because you can help contribute to the general knowledge of where light is and where it's dark, and then you can measure how dark it is and then find ways to reduce it. Okay? So another thing that we could do is pretty cool that we live here in San Pete, and we're lucky. 2 out of 10 people can't see the Milky Way. Most people live under polluted skies. So an example of that I want to show you is this right here. So this says LA, Los Angeles earthquake. So in 1994 there was an earthquake, and when this happened the power went out. And the power went out, so imagine all these lights in LA disappearing. And people started calling 911 because they thought they were being abducted by aliens. They thought horrible things were happening because they saw stuff in the sky that they'd never seen before. And those things were stars. Right? So they were so traumatized by the things happening in the sky they've never seen, never experienced. Planets, stars, maybe the moon, that they were calling 911 and asking, what the heck's happening? Right? So those people can't see the stars that we can see because you can see the sky glow in this picture. So there's some other things that we can do to solve light pollution, to minimize it. So the main thing is just better lighting design. Step 1, turn off the light. Number 2, as you install lights, you want to have your lights installed this way, right? So you want to have them shielded. So all light going upwards is a waste of energy, a waste of light. And if you notice, some of the new lights around town, the new street lights, are designed this way that they point LED lights and they point down. Some other lights are like globes, right, and they shine in all directions. Those are bad lights. So when you have an option to choose lights, you can choose them like this. So I hope you all go home and tell your parents and look at your lights at the front of your garage or whatever and see if they do things like this. So step 1, we can shield our lights. The next thing we can do is we can choose a good color. So like I mentioned earlier, in order for your body to sleep, you need to relax your eyes, and you need red light. So the left-hand side is good for this. 2700 Kelvin red light Those light colors are good for going to bed, for nighttime. They're also good for street light colors. What's bad and makes it brighter and glow stronger is the right-hand side, the daylight over on this side. So you can just choose a light, just changing the light bulb outside from a white light to a red light will help reduce the amount of light pollution and air glow. Questions? Okay, so the next thing is we can check the intensity of the light and warranting. What this means is sometimes we make too many lights, so we don't need all the lights. So you can reduce the number of light bulbs you have outside, or the number of poles in the street, or lights in a parking lot. We don't need all the lights. And also, most LED lights nowadays have little things that you can tone them down. So you can put on a dimmer and make them so they're not so bright. You don't need a light that's bouncing off of the street and then radiating back up into the sky. You can tone it down a little bit. Okay. So there's an organization called the International Dark Sky Association, and they have a sill that they put on lights, and you can go to Home Depot and buy these kind of lights. And they put this stamp on lights, fixtures that people can buy, and their website has a whole bunch of lists of them on all sorts of different types of lights that can be used to make. What these are is if they have the seal of approval, that means they're good for light pollution, right? They reduce light pollution. They're shielded. They're pointed down. They are the right wavelength of color. Okay. Another cool thing is this month, actually, I planned this actually with me and the governor. This month is Utah Dark Sky Month, as declared by Governor Cox. And it just fortuitously happened that I'm speaking the same time that he said this. And so the cool thing about where we live is there are lots of places nearby that are dark sky places, dark sky parks, dark sky towns. And so the governor declared it this month, and so there's a website you can go to and learn more about it. There's a thing called astrotourism. Astrotourism is where people can go out and do like tourism, go on vacation, and part of their trip includes going to places where it's dark. So here's a map of Utah, for example, and we have 5 national parks that are dark sky parks, and something like 10 state parks that are dark sky parks. And then the town of Torrey and the town of Helper are both dark sky communities. And the interesting thing is the city of Helper is bigger than Ephraim is. So their city is bigger than us, and they have a train depot going through their town, and they're still a dark sky. So we're smaller, so here in Ephraim and other communities nearby, all of Sanpete County really, and other counties nearby, could all become dark sky places. The only requirements is that you have an educational experience like this, and you have some ordinances on the books to help encourage lights to be pointed downwards. So that's the next thing we can do, right? So I encourage you all to, you can learn about ordinances in your city, and so after you check on your own house and make sure your house isn't doing light pollution, you can see if the town you live in has ordinances that at least direct street lights to point downwards. Okay. So the Dark Sky Association is this group, a cohort of people that are interested in light pollution, and they have lots of resources on their website. And in our planetarium, we actually have a planetarium show that will talk about light pollution, so I invite you all to come to the planetarium sometime and watch our shows, including the one about light pollution. And this organization has dark sky parks and towns and communities and places all throughout the whole world. And so I also invite you to join IDA or learn about it on their website. Okay, so now that I've taught you what light pollution is, think about, give me some examples of things that you know that you can think of that contribute, that cause light pollution. Okay, street lights. What else? How about anybody live here at Park Place? Anybody here live here at Snow Gardens? How about those crappy lights on the side of your building? Okay, just kidding. Okay, so, lots of places, lots of towns, lots of apartments have lights that shine out, that do glare and light trespass. Okay, anything else anybody can think of? What? Oh, yeah. So your neighbor's light's coming out their bedroom window. Yeah, so make sure you shut your windows. We can see you in the dark. Okay, so that's right. Anybody else? Yeah, the most obvious source of light pollution. So as an astronomer, I try to look at the stars. I try to get out my telescope and a camera, and I try to look at deep field images. And there's a thing ruining my observations of the nighttime sky. And that thing is called the moon. Okay? So I present to you one of the most beautiful images of the nighttime sky. You can dim the lights a little bit over there, maybe. Do you guys see it? The most beautiful image in the sky is Venus. I also present to you Mars, the rings of Jupiter, Saturn. The new Apollo missions are called, I forgot now, what are they called? Artemis missions. The Artemis missions just went to the moon, and they were trying to take a picture of the Earth. And the Earth was also blocked by this giant sky circle in the sky that was ruining our experience of looking at our own sphere called the Earth. Even the sun is blocked by this horrible sky circle. So if you notice that the moon causes two things that I see. First, it causes light pollution. There's 2 weeks out of every month where we can't do astronomy because the full moon or the phases nearby are ruining our chances, our experience of looking at deep space objects. Also, it's occluding, that's what this word is, they're occlusion of things behind it. We can't see the deep space objects like these planets that I'm interested in. So, short of stilling the moon or shrinking the moon, I'm going to give you a couple of proposals of ideas of how we can diminish the light from the moon or get rid of it. And we're going to talk about feasibility, which is like an economy thing, and see what like the cost-benefit analysis of the payback is of these different scenarios, okay? So I present to you my moonshine occlusion reduction feasibility study. So I'm not an economist, but I'm going to pretend to be one for a minute. Okay, so step one. So a couple options. The first one I want to talk about, option one, we can actually do nothing. If we do nothing, we wait around long enough, the moon is leaving. The problem will solve itself. If we wait long enough, the moon will leave and no longer orbit the Earth. There's a problem with this. The astrophysicists among you will notice that the sun will explode in 5 billion years. So I don't know if we have the time scale to wait for 50 billion years for the moon to drift and move away from the Earth. But one advantage this one has is it is cheap. Okay, option number two. We could paint the near side black. So this isn't going to solve the problem of occluding the things behind it, but it will reduce the light pollution problem, which is what the whole point of my talk is. So this is a very good option for this. Okay, so what we could do is, here's the moon, and we could get we get rockets, and we send those rockets, and we air squirt black paint onto the moon. And you don't want to have astronauts with rollers. That will take up too much time and effort and waste of talent for the astronauts. So you want to have air bursters, and you're going to splatter the paint onto the moon until you can no longer see it. This is actually quite doable. The size of the surface of the moon is actually the size of Russia. So we need 19 million square kilometers of terrain covered with paint, which comes out to be, we need about 10 to 11 cans of black matte paint. It can't be glossy, okay? It has to be matte. This costs something like $6.5 trillion. So we're going to have to up our chemical production of paint. That's what I see. Okay, so but the I see, though, is that the rockets is where the problem is. This is going to require a ton of rockets. So these are like the rockets that we send up, NASA sends up. And we're going to need something like $1.3 quadrillion, which is 21 years worth of GDP for the whole world. Okay, but think about this for a minute. When NASA sent the astronauts to the moon in the Apollo missions, for every dollar they spent in the economy, they brought back $10 to improve the economy. So if we could do this, we will grow the economy of the world. I will get a parade down New York. Okay, next one. Okay, maybe that one's not so good. All right, so anybody know what this is? This is not the moon. you will notice that this is not the moon. This is actually Ceres. Ceres is a giant asteroid in the asteroid belt. So what we do is we grab Ceres and we smash it into the moon. This is actually quite easy. So it's going 17 kilometers per second right now in orbit in the asteroid belt. We need to reduce its speed down to about 16 kilometers per second. And we need to give it enough energy to break the binding energy that keeps the moon and all of its little bits in orbit around this Earth. We need to give it to send it from the asteroid Ceres onto the moon. But there are some downsides. But I think that these can be avoidable, okay? So I have an animation to show you, and Pixar better look out, because, so here is the moon, and if I'm gonna shoot an asteroid at it, there seems to be a problem. That problem is that there are people on the Earth. So what I'm gonna do is the asteroid Ceres crashes into the moon, and there's quite a bit of debris. So all we do is move the people to the other side. Disaster diverted. All right, so here's the real problem. So it turns out, this is the rocket equation. You don't need to, there's not a test at the end of this. But the rocket equation says how much fuel you need to move an object. So you need about 1.5 times the mass of Ceres in fuel to move Ceres, the asteroid, from the asteroid belt to the moon. So if you do the math in the rocket equation, this comes out to be 1.5 times 10 to the 21 kilograms of fuel. Does anybody know what fuel is made out of, rocket fuel? It's made out of hydrogen and oxygen. It just so happens that 1.5 times 10 to the 21 kilograms is the exact amount, give or take, okay, the amount of water on the Earth. So we grab all the water, we transport it to Ceres, we separate it, because hydrogen and oxygen separate into the parts needed to make rocket fuel. Then we can use it to smash the moon with the asteroid Ceres. The benefit about this is that nobody's going to complain about there being no tides in the oceans when there are no oceans. Okay, so maybe you don't like that option. Okay, so maybe the next option, maybe you've heard in the news recently, there's the mission called DART. DART was this little mission the size of a vending machine, and they smashed it into a small asteroid. And the whole point of this mission was to see if we could divert the asteroid so it would smash into the Earth. The problem with this is DART is pretty small. So this is kind of like stopping a semi-truck with a bunch of mosquitoes. So if we take something like 10 to the 18 darts, okay, so that's one with 18 zeros at the end of it, that many darts, we can smash them into the moon, and we can do the same thing, we can make them move. Okay, but so what this is really showing, though, look how expensive this is. This is really showing that so far the best option is painting the moon. If we paint the moon, problem solved, right? So on the side, I'm actually going to start investing right now some money into the paint companies, because that seems pretty reasonable now. Okay, all right. So my next option, 4. I hope you guys are taking notes. Okay, so the next one is we could use a very large laser. So I'm not allowed to mention copyright infringement, what laser I'm talking about here. So here's my version of it. I don't know if you know this, real quick. I don't know if you know this. Lasers don't do that. Okay? That's not how light works, just so you know. Okay, so here's my version of it. The problem with this is it's technologically infeasible, so I need a whole bunch of lasers and I need to point them at the moon. The problem with this is you need the output of the sun over 15 minutes, right? All the energy the sun makes in 15 minutes, you need to squeeze that into one burst of light that shoots in seconds at the moon. And the only closest place to do this is the Earth. So guess what happens to the Earth? The atmosphere is ionized, and the entire atmosphere is vaporized, turned into a plasma, and we all go goodbye. So this is probably not a very good solution. Okay. My last solution to the problem of light pollution from the moon is called the Dyson planetary motor. And it was invented actually in the 1960s by this guy, Freeman Dyson. And what it basically is you put conducting material rings, like copper, pipes around wires around the moon. And then you put current through it. And what you're actually making is a giant AC motor. And then you grab little asteroids, and you take those asteroids. See my animation skills? I've used every PowerPoint feature there is. Okay, so you're going to grab the little tiny asteroids now, and most of them are made of metal materials. Those metal materials are magnetic. So as they swing by the moon, they'll interact with the copper wire and the pipes and the wires going around the moon, and it will transfer it will cause a torque, and it will accelerate the moon faster and faster. And every time we send an asteroid around the moon like this, it will cause the moon to spin faster. So we send the asteroid back around the sun to pick up angular momentum from the sun and fling back to the moon, and we do this lots of times. And as we do this lots and lots of times, the rocky bits of the surface of the moon at the equator will start to be going the escape velocity. When they're going the escape velocity, that means they're fast enough to fling apart. So the moon will fly apart like this. And the moon will just fall to bits. So this is actually quite easy because we need a large use of in situ resources that are already on the moon. So we need to build a whole bunch of fusion reactors on the moon to create the electricity in those rings, which I hear is very simple because hydrogen fusion is just a matter of getting really small things to get really close and go really fast. So I think that's pretty easy. We can do that. All the things we need are there on the moon, and physicists have been telling me for the last 60 years that fusion is a simple thing that we can do within the next 30 years. So the cool thing about this is the benefit of this from an astronomy standpoint. As an astronomer, we also get to see the formation of planetary rings at a close scale. So this will be our nighttime sky. We will see rings forming, which makes our planet way cooler, that now we have rings. Okay, so I have put all these ideas in a matrix so we can do some cost-benefit analysis. And I've taken the liberty to say that anything that might wipe out all of people, all civilization, I put those in black. Those things are probably not very economically beneficial to us. So what you see, based on my little graph here, is that building a Dyson planetary motor is at least 2.5 times better than simply doing nothing. I'll let you look at that for a minute. Did I mention the part about the aliens? Where's the alien line at? Oh, does it say that? Engineering appeal. Oh yeah, protection from aliens. Do you see that line? Okay. All right, and with that, I will answer any of your questions that you may or may not have.
Any questions? Yes.
I just want to know if you calculated all of those problems and if you actually came up with all of those solutions.
Some, yes. So there is a book called What If by the maker of a website called XKCD that makes science comic strips. And so some are from him, but then some I calculated also. And so a mix of both. But I calculated a bunch of them, yeah. And all of it is just simple physics and just knowing the mass of things and how much energy stuff takes to move, yeah.
So I was a little curious, like, if your class was able to like observe the moon, would you be able to like see if asteroids even like make a collision course for the moon?
So we observe the moon. Can we see if there's asteroids going to hit it? You mean?
Yeah, like while you're observing it, if asteroids were hit, like.
Yeah. So I think generally they'd be too small to even see the impact, but we do see shooting stars on the Earth in the Earth's atmosphere. But to be able to see them hit the moon's surface. So NASA has a program where they detect things that are coming close to the Earth. So as I do this, if I was to do this in real life and Ceres was to come in close to us, NASA has a whole team of people that are like looking out for things coming close by. And some of them they watched for a long time, and some of them were surprised by. So if you, sometimes in the news you'll see that, oh, they just saw a meteor flying by and it's whatever times closer to the moon than whatever, right? So those measurements, we're always surprised by new asteroids or meteors flying by close to the Earth. But generally they're too small to cause any damage to us or the moon. And so you'd have to be pretty big for us to see it on the moon, right?
Wouldn't a planetary ring system arguably occlude more of the night sky and diffuse more light than the moon?
Well. That's an excellent point. But we do see, I don't think you understand the awesomeness of making rings around our planet.
So how feasible would you say it is to get like even like 50% of cities to be dark sky cities?
Oh, good. A real question about light pollution.
Yeah.
You know, so I don't think it's that hard. And I actually have a 4-page document here with all the ordinances that you could like implement like Helper. And it's not so much that we're getting rid of all the lights, it's just that we're reducing the ones we have and we're making the ones that we need, leave those ones on, but the extra ones not on, right? So, and it's not even, like the ordinances don't even enforce you to do something at your house, but if people are educated about this idea, that as you're gonna update your lights in your house, or as a city is gonna replace the lights with new street lights, as right now a lot of cities are going into new LED lights or whatever, as they do that, if you're at least aware of this idea, then it's a simple choice that you buy this light instead of this light, and the prices are the same, they look nice, they have nice aesthetic, appeasing different kinds of lights for different scenarios. So I don't think that light pollution will go to zero, but we can reduce it a lot. If people are aware of it and conscious of it, and like city planners or whatever are aware of it. Yeah. Good question. Thank you for asking about light pollution. It's not every day that you come to a seminar where they blow up the moon.
What made you want to talk about light pollution, and why do you feel it's like super important to fix?
Why do I like light pollution? Well, because I'm an astronomer, right? So my motivation is that I like looking at the stars. And here in San Pete, we have the advantage that we can do it, right? So if you've ever gone at nighttime away from the city lights and seen it, like, it's amazing. It's cool. It's inspiring. And lots of people can't see it. And when I take my astronomy class every year out and go look at the stars, and the first reaction they always say is, wow, right? Like that's a cool phenomenon that we can see the whole universe, but not in a big city. So that's why I think it's important. We're keeping you here till 3 more questions are asked. Just kidding. Yeah. Fires? Sure, but they are usually like a bonfire. Usually fires are smaller. Usually little fires are smaller. Bonfires even, maybe. But they're on the red side, right? So that's even already better than daylight colors. Yeah. And usually they don't last very long, right? Usually it's one night. I guess if the hill was always on fire, that would be a bad idea. But a one-time fire, it's fine. Okay, so write a letter to whoever it is over the prison and get them to turn the lights down. Lights are too light right of the prison. And Walmart and all your apartments, wherever you live, apartments, that's your job. Put stickers on the lights. Yeah, thanks for coming.
For those students